In this lesson, we focus on financial mathematics. We shall look at simple interest, compound interest, annuities, and a lot more, and we're getting started. Now, sinking funds are very, very important in mathematics of finance. Companies often purchase equipment and use it for a special period of time. The old equipment is then sold for a scrap value. A new upgraded equipment is bought. So now when you sell old equipment, it is said to be sold at a scrap value. And the new upgraded equipment is bought obviously afterwards. Okay, right. In order to finance the purchasing of the new equipment, the company will have, well in advance, set up an annuity called a sinking fund. So now, in order to finance the purchasing of the new equipment, the company will have, well in advance, set up an annuity called a sinking fund. So in other words, an annuity that is called a sinking fund is set up by a company in order to replace old machinery. Right, old machinery. But now they actually set up an annuity. And an annuity means they have this series of payments that they make continuously to save money in an attempt to replace the old machine at the end of its lifetime. A sinking fund is nothing more than a normal savings plan or a future value annuity. What is a sinking fund? Is nothing more than a normal savings plan or a future value annuity. The proceeds from the sinking fund and the sale of the old equipment is then used, to purchase the new equipment. Right, so we are dealing with sinking funds. And what is a sinking fund? A sinking fund is nothing more than a normal savings plan or a future value annuity. Right, so this is what we call a sinking fund. Now, a sinking fund is set up to replace old machinery, right, to replace an old car, to replace an old truck in your business, etc. There at home, you set up a sinking fund. On a farm, you set up a sinking fund. There's an old tractor you wish to replace, and a sinking fund becomes the most appropriate to set up to replace the old machinery. We proceed. A school purchases a photocopying machine for 150,000 rand. So that your school, they decided to actually purchase or buy a photocopying machine for 150,000. The machine depreciates in value at 22% per annum on a reducing balance. The school wants to buy a new machine in 5 years' time. A new machine will cost much more in the future, and its cost will escalate at 19% per annum effective. So now we're speaking of what you call effective interest. So there are two competing interests called their effective interest and also the nominal interest. The old machine will be sold at a scrap value after exactly 5 years. Right, now a sinking fund is set up immediately in order to save up for the new machine. The proceeds from the sale of the old will be used together with the sinking fund to buy the new machine. The school will pay equal monthly amounts into the sinking fund, and the interest earned is 14.4. It's exactly 14.4% per annum. Right, so this is sort of what we have here. And we continue to analyze these very, very carefully. Compounded monthly. The first payment will be made immediately, and the last payment will be made at the end of the 5-year period. Right, so now we continue with the analysis of this question. Find the scrap value here. Find the scrap value of this particular of the old machine. Next, find the cost of the new machine, right, 5 years from now. Okay, next question, we shall find the amount required, right, amount required in the sinking fund 5 years from now. Find the equal monthly payments made into the sinking fund. So we proceed as follows. Right, so the first question is, want to find the scrap value of the old machine. And how do we then determine the scrap value of the old machine? Right, and we proceed as follows. Because the old machine is old and therefore it depreciates, we have the following. Right, so we have that A is P, 1 minus I to the nth power. But the couple of things that we know, 150,000, right, is the actual value of the photocopying machine by the time it was bought, and we have 150,000. 1 minus the percentage, which is 0.22%, raised to the power after 5 years. So you put these to the 5th power, and we have approximately. Okay, so now what then do we have here? 150,000. 1 minus 0.22, and you raise it to the 5th power. And now, obviously, see, the question was determine the scrap value of the old machine. So this old machine will depreciate on the reducing balance, and its value will become 43,307.62. It will become exactly 43,307.62. So this becomes the actual scrap value of the old machine. Any question?
No, sir.
No question. We move forward. Find the scrap value of the old machine. Right. What is so now we actually have done that. Find the cost of the new machine 5 years from now. Right, the new machine will appreciate, and therefore we use the formula with the plus. 1 plus I to the nth power, 150,000. 1 plus, you divide the 22 by 100, and we get 0.22. And we raise these to the 5th power. And this is approximately what? So now we're going to use this here. 150,000. 1 plus 0.22 to the 5th power. Right, 405,406. And right, let me see what we have done. Okay. Take note of the fact that a new machine will cost much more in the future, and it will escalate at 19%. So you take the 19%, 19 divide by 100, so that it is 0.19. Right, so now you therefore have that 150,000 has been recorded as the price of the machine that was bought initially. 0.19 you close, and it is to the 5th power. So that in the end, it is 357,953 Rand and 05 cents. 357,953 Rand and 5 cents. And this is the cost of the new machine 5 years from now. 357,953 and 05 cents. Now, the couple of things here, because we're saying the machine depreciates in value at 22%. A new machine will cost much more in the future, and it will escalate at 19%, right, per annum effective. So it is effective interest. And therefore, now the escalation. So if we want to find the cost of a new machine, right, we'll then have to use the 19% there. And we're able to see that it is exactly 357,953 Rand and 5 cents. Next question. Next question. Find the amount required in the sinking fund 5 years from now. The question is, what is the amount required in the sinking fund exactly 5 years from now? So now, to do this, we actually normally use the following formula. Right, what is the formula? Sinking fund. Right, so the sinking fund equals, or rather the sinking fund plus the scrap value, plus the scrap. Sinking fund plus the scrap value is equal to the cost of new machine. Right, the cost of new machine. Sinking fund plus scrap value equals cost of new machine. We manipulate. So in other words, the amount of money we save through the savings account plus the scrap value, which is the money we get from selling the old machine, the old car, we add the two, the savings together with the money we get from selling the old car. So it's sort of the trade-in value. So now you combine the money you get from selling the old machine and the sinking fund from the savings account, it becomes the cost of the new machine. So I want to know, find the amount required in the sinking fund. So we need to find the sinking fund formula. Now, this means that the sinking fund, right, the sinking fund, you can make the sinking fund the subject of the formula. Sinking fund equals cost of new machine minus scrap value minus scrap value. Then we have the sinking fund. Right, so the sinking fund what is the cost of the new machine? We have already found the cost of the new machine. The cost of the new machine is actually 357,953.05. So we write here 357,953 rand and exactly 5 cents minus the scrap value. The scrap value, if we actually consider the sales of the old photocopying machine, it's actually obviously 43,307 rand and 62 cents. And that is what we substitute here. 43,307 and 62 cents. Meaning here we're able to get the sinking fund, and the sinking fund equals. Use our calculator in the exam as follows. You're going to take 357,953.05 minus 357,953.05 minus 43,307.62. And this is actually exactly 314,648 rand and 43 cents. Right, so we write down the sinking fund 314,645,43. And this is the sinking fund. Find the amount required in the sinking fund 5 years from now. And therefore, the sinking fund is exactly this value there. Next question. Any question?
No, sir.
No question. We move forward. Now, find the equal monthly payments made into the sinking fund. Find the equal monthly payments made into the sinking fund. Right, so now we're interested in finding the equal monthly payments that have been made into the sinking fund. And we proceed as follows. We have a timeline. And we're able to see that at this point, we want to find the equal monthly payments, and the equal monthly payments made into the sinking fund. We have T0, T1, T2, T3, like so. We have T60. T60 is after 5 years. Right. And then these are monthly payments. So 5 years by 60 months gives us that. T59. X, 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 X. Can put T58 here. X, X. Which means I is equal to. Now, the school will pay equal monthly amounts into the sinking fund, and the interest end is this one per annum compounded monthly. So you'd have to take this one here and divide by 12. 0.144 divided by 12 equals what? Right, 0.144. And it's divided by 12 months in a year. This is actually 0.012. 0.012. Okay. This means that we know that the future value is f equals x, 1 plus I to the nth power, minus 1 divided by I. Find the equal monthly payments made into the sinking fund. The sinking fund is 314,645 Rand and 43 cents. So the future value is exactly 314,000.
Sir,
Yes.
can I ask
Yes,
when?
please.
Okay, so for seeking fund, we always use future value.
Okay, that's a good question. For sinking fund, yes, because we're saving for the future.
Okay.
By and
So, sir,
large, yeah, we're saving for the future because a sinking fund is like a savings account.
okay.
Yeah, a savings account, normally it's money that is not there, and we want to have a certain amount of money after 5 years. So it makes sense that by and large, we actually use the future value formula. Okay, right. So that now 314,000, there are some exercises you're going to do today here with me. Right, 314,645 and 43 cents. And this equals, right, equals X. 1 plus. Now we already have the interest rate, which is 0,012 raised to the power. Now, the couple of things that remain very, very important. Now, the school will pay equal monthly payments into the sinking fund, and the school want to have the money in the future, meaning obviously the future value formula becomes the most applicable. And the interest earned is 14.4% per annum, compounded monthly. But there's more information. The first payment will be made immediately. The first payment will be made immediately, and the last payment will be made at the end of the 5-year period, meaning we shall actually therefore have the +1 rule, and the +1 rule says we shall have therefore 61 payments, not just 60 out of the 60 months. We shall have 61 payments. The +1 rule applies, and we divide every single bit of thing by 0,012, like so. With this mentioned, We proceed now and we want to solve for x. Right, and to solve for x, we obtain the following. So if it is true that this is what we have, 314,645 and 43 cents, which equals x. 1 plus 0, 012 to the nth power minus 1 divided by 0,012. X equals 314,645.43, 0,012. We continue. And it is divided by 1 plus 0,012. Okay, yeah, it is raised to the power of 61 here, with a total of 61 payments. And we just cross multiply and we actually able to get this one, and it's raised to the power 61 minus 1, like so. Upon careful examination, we're able to get the actual value of x, the equal monthly payments that will yield the sinking fund. Let's check. So what we're able to achieve here, we have exactly the following. 314,645. 314,645.43 times 0.012 divided by 1 plus 0.012 raised to the power 61 minus 1. Now, this is what we're getting. Let's check this out. We get exactly 3,528 and exactly 9 cents. 3528,09. 3528,09. So that in the end, we actually had to find the equal monthly payments, and we used the future value formula, and we're able to get the answer to this particular question. And we move forward. Okay, we discussed what we call deferred annuities. In many situations, the repayment of a loan begins 1 month after the loan has been granted. However, circumstances arise where the repayments are deferred or delayed payments for an agreed period of time. For example, if you borrow money to start a small business, it could be a few months before the business is set up and begins to acquire income. In such a situation, the repayment of the loan could be structured so that the first payment begins after an agreed period of time. A 20-year loan of 100,000 is repaid by means of equal monthly payments starting 3 months after the granting of the loan. The interest rate is 18% per annum compounded monthly. Calculate the monthly payments. Right, let us look at this one here, but look at this very, very carefully. We're going to use a timeline to do this particular question. we start from time 0, time 1, time 2, and so on. Time 240, time 239. Now a 20-year loan of 100,000 is repaid by means of equal monthly payments, starting 3 months after the granting of the loan. So that we have X, X, X. And you can do T3 here, X. We need to calculate the monthly payments. And now we need to say, we can put T4 here. X. So that then in the end, we have 100,000. Is repaid by means of equal monthly payment starting 3 months after the granting of the loan. So now there is a gap here. And now, because these are monthly payments, you're going to count 1, 2, 3 months. And therefore, in the case of the deferred annuities, it's an annuity, but it's delayed. Because right now, then it means the payment can only start 3 months. The interest rate, I, is exactly 18% per annum, but is compounded monthly. Yes, please.
So I wanted to ask,
Yes.
how did you get 240?
How did I get 240? Right. Now you need to obviously be in a position to take into account that this is a 20-year loan. Right. So you take N equals 20 years multiplied by 12. And it is actually exactly 240 months.
Yes, sir. Thank you, sir.
Okay, good. Right. So now in the end, then we're able to then say, what then is the interest rate monthly? So it is 0.18. You divide by 12, which is 0.015. So at the present value, it's X open bracket 1 minus 1 plus I raised to minus N divided by I. Okay. Now this is a loan we're dealing with, and a loan is a present value situation. Okay. Let us reason together here. We're then thinking it is a 20-year loan of 100,000. Is repaid by means of equal monthly payments starting 3 months from now, after the granting of the loan. With that mentioned, it means that we need to calculate the monthly payments. But there is a gap here. There is a gap. Because this loan is actually such that it will be repaid by means of equal monthly payments starting 3 months after. So there's a gap. Now, pay attention. If this is the gap, it means the 100,000 it's gonna have to be moved to that particular period precisely. We have to take it and move it 1, 2, at least. 1, 2. And by the minute it gets here, then we shall be sorted, because now we shall be having 1 month, 1 month, 1 month, 1 month. So, which means that here we're going to use 1 plus 0.015, 2. Exactly 2. Okay, let us see what to do here. What we're effectively saying is some of the questions you're going to do, because I have with me tons of problems that you're going to solve. But some of them you're going to participate because I'm still laying the foundation so that some of the things you might be seeing them for the first time in your life. But now you start with the 100,000 using the appreciation formula 1 plus 0,015. And there it is 2 months forward, 1, 2. And then it is x 1 minus 1 plus 0,015 raised to the power. Now, if then we move everything here, it means that we shall deal with the period. And it's going to be 240 minus 2. Yes, please. Giving us 238. Yes, please.
I think it's 18%.
Please come again.
I think it's 18%. You wrote
Yes.
15.
Yes, it is 18%. I agree with you. But remember, I used the 18%, but it's compounded monthly.
Oh, divided by 12. Okay,
We
sorry.
divided by 12. Okay, that's fine. Thank you for noting that. So we divided by 12. Thanks for engaging, because I want more engagement. 2, 3, 8. Close bracket, all divided by 0,015. Okay, I'm going to give you some activities. You still have a question? Yes, please.
One more question. You see for the appreciation formula.
Yes, the appreciation formula that we're using here. So
Yes, so
yes.
you put it through. How do we know the difference when it's years and months? Because sometimes with years you can just put a 5 day for 5 years. I think in the last example we did that.
Yes,
And
yeah, definitely. So it depends on the compounding period.
yes, so
It depends on the compounding period, because now if it is in years, then you just put 5. But you put a 5 here even the interest rate is annual, is per annum, so it doesn't change as well. If you put the 5 here, it means the interest rate is going to be taken as it is. Like here, because it's 18%, but we're putting 0.015 because you converted the 18% to a monthly rate. And so obviously now we're putting the 2, and the 2 is the number of the months.
okay.
Right. So yeah, you note that. So now, what exactly is this here? Okay, you can write 10, like 100,000. Just write 100,000 here, because it is a 20-year loan of 100,000. So You have 100,000. 1,015 squared, which equals x. Then you have 1 minus, you have here 1,015 minus 238. You divide by 0,015. So x equals 100,000. 1 comma, cross multiply. Right, if you cross multiply, we then get, let me do it in green color. So now you do it in green color, we solve for x, and therefore x equals 100,000, 1,015 squared. If you cross multiply, it's going to be multiplied by 0,015. And it's divided by 1 minus 0,15 minus 238. Okay. So this is approximately, use the calculator to compute this one. Right, so the next one is yours. Hey, I'm loaded with questions, but some are very, very difficult. Some are very hard questions on finance. Now we're going higher on finance. We are dealing with the matric syllabus. 100,000. And then after this, we shall be looking at past examination questions. 1.015. And then you close bracket, you square. You multiply it by 0,015. You close the bracket. You divide by an open bracket. 1 minus 1.015. You close the bracket. Power minus 238. You close the bracket. Right, and this is the answer. We're getting exactly 1,591 rand and 35 cents. 1,591 rand and 35 cents. Put here 1,591 and 35 cents. And 35 cents. Okay, and this becomes the answer. Any question?
No, sir.
Any question? All right. All right, my dear, we move on. We move on. The next question is yours. And it said we're going higher and we are asking tough questions. All right, we're asking tough questions. We move forward. We move forward. Okay, this one is yours. This one is yours. This one is yours. An investor pays 3,000 at the end of each month, starting 3 months from now, into an account paying 18% per annum compounded monthly. Okay. I want to see what you're going to do here. An investor pays 3,000 rand. at the end of each month, starting 3 months from now, into an account paying 18% per annum compounded monthly. He pays his final right 3,000. Okay, he pays his final 3,000 rand 6 months before the time he wishes to withdraw the money. He's going to withdraw some of the money, but he pays his final 3,000 6 months before the time he wishes to withdraw the money. So he realizes that he says, you know what? I'm going to pay my final 3,000 6 months before the time he wishes to withdraw the money. If the investment period starting now is 8 years, the investment period is 8 years, calculate the future value of the investment at the end of the 8th year. Okay, I'm giving you 2 minutes to think about this question. To think about this question. Right.
Does that mean including the 6 months or after the 6 months?
Okay, let me see. Does it mean including the 6 months or, well, obviously, I mean, the period, all the periods count, but we're going to do it together, obviously. All the periods must be taken into account. All circumstances must be taken into account. It's a tricky question, but I'm giving you 2 minutes or 3 minutes. Let me give you 3 minutes. And then we're going to do it. I know it's not very difficult. It's not very difficult. It's not very difficult. Right. It's not very difficult. About life. Right. Please let me know when you're done. Right, please let me know when you're done.
So I think I have an idea of what I'm supposed to do.
Okay, you think you have an idea of what you're supposed to do. What do you think you need to do? Let me give you a chance first.
So we're gonna use the future value
We're gonna
formula.
use the future value formula. First things first, the future value formula. Well done. Yeah.
Yes, sir. And then with the if
Yes.
it's going to be our A
Yeah.
basically. So it's going to be P is equal P bracket 1 plus I to the power of n. That
Well
is for the
done.
three.
So obviously at this point, we're gonna use the future value formula. Well done. So you actually obviously have an idea of what to do. So the future value formula is x open bracket 1 plus I to the nth power minus 1 all divided by I. Which means that an investor pays 3,000 rand. So this investor is going to pay
Yes, sir.
3,000 rand. At the end of each month, starting 3 months from now, into an account paying 18% per annum, we saw that the 18% in the previous question is just being repeated. 18% to divide by 12, and therefore it is actually 0.18 to divide by 12. And we saw that it is 0.015. So it is 0,015, and you raise it to, we're going to raise it to power. But first, right now, 18% compounded monthly. He pays his final 3,000 rand 6 months before the time he wishes to withdraw the money. Right, and this period we're dealing with is a period of exactly 8 years. Let us picture what is happening here. Let us picture, using a timeline, the ball game, and see exactly what is happening to make sense of this. So this investor is a very, very clever investor, and is cunning. Is actually using investment techniques. And he decides that, you know what, I'm very smart. He pays 3,000 at the end of each month, starting 3 months from now. So now if we're going to be doing everything every month, time 0, time 1, time 2, time 3, time 4, time 5. So now, obviously, this investor pays 3,000 at the end of each month, starting 3 months from now. So now you count 1, 2, 3, and he pays 3,000. Another 3,000. Right, into an account paying 18% per annum compounded monthly interest rate. He pays his final 3,000 6 months before the time he wishes to withdraw the money. If the investment period starting from now is 8 years, calculate the future value of the investment at the end of the 8th year. Now, we need to consider the following. So you need to say N equals, right, N equals. Now, if we then say N equals exactly the following 8 years, right, 8 years, and you multiply by 12. So now let us come here. I want to use a calculator. Right, so obviously we shall take the rest of these explanations into account. So you have 8 by 12, right, and which will give us 96 months. So this would give us exactly 96 months. Okay, 96 months. Okay, 96 months. So now we have 3,000 there as well. Okay, now good. But now look, at the end of each month, starting 3 months from now, into an account paying 18% per annum. But now remember that is starting 3 months from now. So you're going to count 1, 2, 3. So in other words, we're able to see a gap. We're able to see or realize a gap. Now, there are a couple of things that you need to take, obviously, into account. Now, here, it's going to be such that in the end, in the 8 years, we have 96 months. But there's more to that, because there's T95, T94. So in which case, now we're going to say, okay, remember that he's going to be such that he is clever, and he pays his final 3,000 6 months before the time he wishes to. 6 months, so you're going to be doing that T90. Okay, let's just include that one up to T90. Right, so now you'd have like T90. There's something happening at T90, because now he pays that, so that you have 3,000. But now this T90 is exactly 6 months. It's exactly 6 months. Right. He pays his final 3,000 6 months before the time which is to withdraw the money. So he pays up to there. You have exactly that period there. Okay, so everything is good. And now, what exactly is happening? The time before he wishes to withdraw the money. If the investment period starting now is 8 years, calculate the future value of the investment at the end of the 8th year. Now, look, this is easy. But now, because of the gap, we shall do 1, 2. And then we shall then say, we note that obviously there's a gap of exactly 3 months. And now we wish that everything is done exactly every month. Okay, good. So if we then say, we shall count a total of how many payments then, that is what you will have to do. So in other words, you'll have to take 90 minus 2. Out of 90 minus 2, and you get exactly 88. So that here would have n has power, the n is 88 minus 1. You divide by 0,015. And then you multiply by 1,015. And then now you then say, but now you stopped paying. And then now for the 6 months, then you're going to put 6 here. Like that. Okay. And then obviously we take note of the fact that the earn is 8 years times 12, which is exactly 96 months. Like so. We're good. So now, okay. Now let us use the calculator to just compute the answer here from this point onwards. So 3,000 1 plus 0.015 to the power 88.
Sorry, sir. Can you please explain the 88 and the 6 again?
Okay, yeah, I'll just explain just now. Let me just actually use the calculator, and then I will explain. Okay. Right. So you divide everything by 0.015. 0.015. Okay, we're good. We're good. We're good. We're good. We're good. Let me check. Okay. Okay, right. Okay, yeah, I'll just explain now. I just want to first finish the computation with the calculator. And then this is multiplied by 1.015. You close into the power 6. To the power 6. What is the answer? Okay, wait a minute. I'm still checking to make sure that everything is okay. 591,969 rand and 90 cents. 591,969,90. 591, 591, 969, comma 90, comma 90. Okay, so this will be the future value. You wanted us to discuss the 88, is it correct?
Yes, sir. And the 6.
And the 6. Okay, right. Now, the 6 must be understood to mean that the future value is going to be our A, right? So because now it's going to run for the number of the payments, which will be 88 terms altogether, because we are dealing with the fact that an investor pays 3,000 at the end of each month, starting 3 months from now, right, into an account paying 18% per annum compounded monthly. He pays his final, right, 3,000 6 months before. Okay, if he pays 6 months before the time, so 6 months before would be, okay, because the total number of months is 96, so you're going to say 96 minus 6, which is 6 months before, and then you're going to get exactly the 90, so that obviously then we are sure that there's a payment that's going to be done at time T90. But be that as it may, we are sure, therefore, that at T90, okay, what then do we have? It therefore follows that would have 2 months, because now there's a gap here, and we want to make sure everything is 1 month away. Everything is actually 1 month away. And therefore, it means that the future value of the payments would actually therefore be conducted as follows. And it will actually therefore become 90 minus 2. 90 minus exactly the 2, where there was where the gap. And so now we then say 90 minus these 2 months, it's going to give us exactly 88 months. Right, and therefore, we shall therefore say, after we then said 90 minus the 88, we would then be in a position to put n equals 88 months there. But the 6 would be, okay, you have 6 months from T90 to the end, and there are no payments at all. Because there are no payments at all, it becomes compound interest. As you said, it would actually be that we're going to use the formula A equals 1 plus I to the nth power. Okay, look at this and think about this, but look at this very carefully. Right. Because he only started at T3, it means that 2 payments were missed. 2 payments were missed. Because he only started at T3. If he started at T3, how many payments did he miss? He missed only 2. Right, so now how do you then say he missed only 2? Because he started at T3. So in other words, you must then say 90 minus the 2 payments he missed. You know? And therefore, we then say 90 minus 2, which is 88. Then we fly everything through with the 1,05 to the 6th power. And we're able to then get the answer. Any question?
So the 6 months, why are we still doing it for 6 months if he stops paying the 3,000 then? Does it mean like in
Yes,
the account it's still
it becomes compound interest. Okay, he stops paying because if he continued paying, it was going to affect the annuity formula, the future value. So it was going to change the 88. But now he stopped, and then the 88 is the fixed period of time because it actually ended at this point. But then the minute he stops paying, it becomes a compound interest calculation. So we use A equals P1 plus. So the future value, the F sort of becomes what? Becomes our P. So now this future value becomes our P, and therefore, but we must still reach T96 because we want to calculate the future of the future value of the investment at the end of the 8th year. So we must go up to the end of the 8th year. But how are we gonna go? Because yes, there are no payments. So we must make it a compound interest at the time that there's just money there that is gonna grow in interest terms.
Okay, thank you, sir.
Okay, you sort of understand.
Yes, sir. No, I just want to understand that after he stops investing or like adding the money into the account,
Yes.
it continues to accumulate for 6 years, for
Yes,
6 months.
for 6 months, it continues to accumulate, accrue interest. It continues to accrue interest. Right.
Yes,
So
sir.
now let's continue. I'm gonna give you Andrew. This question about Andrew. Right now, Andrew decides to start saving money. Andrew wants to be rich. If saving can make somebody rich, Andrew is that guy. And he wants to start saving money. 1 month after opening the account, he invests 2,500 per month into an account paying 11% per annum compounded monthly. Right, so we continue. Okay. We continue. Right, so 1 month after opening the account, he invests 2,500 per month into an account paying 11% per annum compounded monthly. At the beginning of the 2nd year, the interest rate changes to 12% per annum compounded monthly. He takes advantage of this opportunity to make his money grow and increases his monthly payment to 3,500. The reversed payments start 1 month after the interest rate changed. How much money will he have saved at the end of the 2nd year? I think I must give you Andrew. Okay, this is a question. You know, it's a form of savings by Andrew, by the guy called Andrew in the question. Okay, so never mind that. I'm trying to expose you to tougher questions. Trying to see what you can do. I'm trying to see what you can do. Okay, let's use the timeline quickly to save time, because it might be a bit more complex for you. Time 0, time 1, but I want you to understand what is happening. Time 2, and then we shall go on. Time 12, and then we shall go on. Time 24, time 23. Look. And Lisa, yes, please.
So I have an idea, I think.
Yes, what do you think we need to do?
So you see with the future value formula,
Yeah.
so you're gonna first compound. So you're gonna say this amount, the 2,500 per month,
Yes.
with the 11% monthly.
Yes.
For I think for 12 months, because it's 12 payments. So for 12 payments that he's gonna do that. And then
Yes.
for the 2nd year, you're gonna add that with the new value, which is 3,500 and compounded 12%.
You're on point. You're on point. Well done. Right. So obviously, because 1 month after opening the account, he invests 2,500 per month. So it's going to be 2,500 there without wasting much time. And then now you're going to see that, okay, it's 11% per annum compounded monthly. So yeah, the 2,500 is at 11%, so which means that it's going to be 1 plus 0.11. You divide by 12 because it's compounded monthly. Right, at the end of the second year, right, the interest rate changes to 12% per annum compounded monthly. He takes advantage of this opportunity to make his money grow and increases the monthly payment to exactly that. So this is going to be exactly B minus 1. I'm going to put the power. And now you need to take into account that these 2,500 per month into an account paying 11% per annum compounded monthly at the beginning of the second year. So now, in other words, this 11%, it's going to be for 12 months. But now at the beginning of the second year, the ball game changes. So this one is also going to be 0.11 out of 12. Okay, so now there's something that is very important. This amount then now is going to, at the beginning of the second year, the interest rate changes 12%. But now for the next year, it's going to become a compound interest. So this one is going to become P in the AP formula, in the AP 1 plus I to the nth power. But now there's 3,500. Yes, please.
Can't I add the two values and just calculate them like that? But the problem is that the interest. Okay, never mind.
Yes, because the interests are different, right? Well done. Right, because now then the interest here, because now you have 3,500 and the interest changes to this compounded monthly. And he takes advantage of this opportunity to make his money grow and increases the monthly payment to 3,500. 1 plus. And then it's going to be 0.12 divided by 12. And this is actually for, it's actually for a year, 12 months, 0.01. Like that. Or you can say, to make things easy, here you can say it's going to be 0.12, you divide by 12. You divide by 12. Okay, now we're going to use a calculator. Okay, do you have a question here? Okay, let me use a calculator first.
No, sir.
Okay, that's fine. You can think about it. So it's going to be exactly 2,500. And then it's going to be 1 plus. All right, and then it's going to be 0.11 out of 12. You close to the power 12 minus 1. Let me see what I've done here. Can we do it carefully? So you do this. 2,500. Open bracket. 1 plus 0.11. You divide by 12. Close bracket. To the power 12. Minus 1. Close bracket. Divided by 0.11. Divided by 12. Times 1.01. Okay, and then you close the bracket. And then you raise it to 12 because it becomes P. So you're going to have that this future value is going to become P in the formula, in the AP formula, plus the following: 3,500. Zero 0.12. You divide by 12. Raised to the 12th power. You close. So, okay. You divide by 0.12. You divide by 12. You close. So this is 79,951. 79,951. 71,951. So this is the answer. It's exactly the answer. So obviously there are a couple of things that are very important here. What we're able to see is that you'd have a timeline like this, times 0, and then here it's going to be 2,500, 2,500. Those are the payments. And then now at T12, it's going to be 2,500. And then at T13, that is 1 year later, it's going to become 3,500. And then we have 3,500. Okay, we're good. Check. So from here to there, there's going to be, here there's going to be I2. And here it's going to be I1. I1 is 0.11, you divide by 12. I2 is 0.12 divided by 12. Right. And therefore this one is 0.01. Okay, and this one 0.0.11, which is exactly that, not the nicest one. So, you can leave it exactly that. Let's see, 0.12, 0.12 divided by 12, which is 0.01. Yeah, the other one you can just leave it that way because it's lengthy. Right, so you have exactly that. So yeah, that is sort of the ball game here. Okay, so that is the answer to the question. We move forward. No question, right?
Yes, sir.
Okay, good. This one is yours. What amount must be invested now so as to realize equal withdrawals of 100 and... Okay, let me check here. This one might not be the correct thing. Yeah, it must be 150,000. Must be 150,000. Must have like 3 zeros. Yeah, 4 zeros altogether. So what amount must be invested now so as to realize equal withdrawals of 150,000 at the end of each year for 5 years? If the first withdrawal is made in 10 years' time, the interest rate during the first 9 years is 16% per annum compounded semi-annually. Thereafter, it is 18% per annum effective. Okay. Let us see what you're going to do here. I'm giving you 2 minutes. Please let me know when you're done. Please let me know when you're done. Please let me know when you're done. Right. We continue. Let me know when you're done. Please let us know when you're done.
I'm not
Yeah.
that well. I'm not sure if I'm right though.
Okay. What do you think?
So I feel like the 15, the 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 150,000 is our if for the first 5 years,
Yes,
and then
because yeah, uh-huh. Okay. Yeah, first let me listen to you.
and then we look for the value of x. That's all I
Mhm.
know. I think that's kind of all that I know. And then
Okay. Yeah.
yeah, but I'm not sure.
All right, that's fine, but way too easy. Way too easy than you think, like we did before. Now, the couple of things you need to take into account. So now, here, because what amount must be invested now, we're going to use the present value formula. X, which is 1 minus 1 plus I to the minus n divided by I. Meaning, I'm going to have T0, T1, T2. Yeah, okay. What must be, yeah, what amount must be invested now so as to realize equal withdrawals of 150,000 at the end of each year for 5 years? Right. If the first withdrawal is made in 10 years' time, right? So that is what you need to take into account. So obviously, if that is the case, the interest rate during the first 9 years is actually 16%. So you're gonna do for the first 9 years up to T9. Then you're gonna put some ellipses this way. So you're gonna allow these to go on for 9 years. I1, which is 0.16 divided by. Right, so now you divide by 2 because it's semi-annually. So it's 2 times per year. 2 times per year. We're gonna see what we're gonna get here. And then now, remember that the interest rate during the first 9 years is 16% per annum compounded semi-annually. Thereafter, it is 18% per annum effective. meaning that after that, it's going to be exactly 18%. Effective. You have the present value here. So that now, then you'd have T10, and this is going to actually go on up to T14, T13. Okay, because obviously we're counting exactly this 150,000 at the end of each year for 5 years. If the first withdrawal is made in 10 years' time, the interest rate during the first 9 years and 5 years. So you have a total of 14 years. Now, this means that you'd have an amount X, X, X. Right. And then now you realize that what is going to happen here at T9, there is an interest rate change. Now, the easiest way to do this question is to say the present value is going to be 150,000. 1 minus 1 plus. Now, there's certain things you need to take into account that we're actually dealing with the... Okay, let us... Okay, this one is it's actually, so you have I1 divided by, use a calculator. Fine, you can simplify this one. I think it simplifies easily. Zero 0.16 divided by 2. Zero 0.08. Okay. So you have 0.08. That's fine. Semi-annually. So now this one is going to be, you're going to take this amount, this amount X. So the present value, if the present value therefore is to sit here, what you're going to do, you're going to take this amount for the 0.18 effective, and you're going to raise it to 5 years, because the 150,000 at the... So now what amount must be invested now so as to realize equal withdrawals of 150,000 at the end of each year for 5 years? Divided by 0.18 multiplied by. Then simultaneously, because by the time you put it back here, because this is like 5 years, by the time you reach to the 9th year, you remember that this amount must be invested now so as to realize equal monthly withdrawals at the end of each year for 5 years. If the first withdrawal is made in 10 years' time, so the first withdrawal is going to be made in 10 years' time. So now, before the 10 years' time, we understand that the interest rate during the first 9 years is this. Meaning that we're going to then say this 150,000 is made in 10 years' time. And then we're going to then say, obviously, it is for 5 years. And we then consider the 0.08. 1 plus 0.08, which is this one here. So this one here, now we're going to, by the time it reaches here, it's going to be like A. You're going to use the formula A equals P 1 plus I to the N. Yes, please.
So why are we assuming that 100? So why are we saying that 150 is the the monthly?
Withdrawal.
It's the monthly withdrawal.
Well, yeah, because, well, the thing is, here it is. What amount must be invested now so as to realize equal withdrawals of 150? So these 150,000 are withdrawals at the end of each year for 5 years. So for 5 years, they're going to be how many of the withdrawals? 5 of them. Because at the end of each year, there's 150,000 that is withdrawn. At the end of each year, 150,000 is what? Is withdrawn.
Yes, sir.
If the first, so they're gonna be 5 of them because it's for 5 years that the 150,000 is withdrawn. But if the first withdrawal is made in 10 years' time, so this guy waits. He says he's gonna start withdrawing in 10 years what? Time. The interest rate during the first 9 years is what? What is the interest rate during the first 9 years? It is 16%. Okay.
Yes, sir.
Now there's something then. You then say, now here, for the 9 years, then you're gonna then say 9 years times 2, so that we have minus 18. So now you're gonna actually realize that this amount, for the first up to the 9 years, then you take it back to like this. Okay, when you take it back like that, you need to find P. So you're gonna use the formula, but you must make P the subject here, which means that P is A1 plus I to the minus N. So that P becomes that. A1, A into 1 plus I to the minus N. All together. So now you take it back using the formula P equals that, but 18 periods. It's 9 years, but it's semi-annually here. So it's times 2. Okay, some of these questions are a bit hectic. Okay, this will be the last example on some of these exercises. I was trying to stretch your mind. And then there are other problems that are coming. 150,000. 1 minus 1 plus 0.18, close bracket, to the minus 5. Then you close. If you delete like this, (0.18). (0.08).
Sir,
Yes, please. And then
my
you raise it to
laptop
the power. Yeah, you're saying?
my laptop is gonna die. I'm gonna join with my phone quickly.
Okay. So this is 117. Are you experiencing load shedding? Okay, that's fine.
Load reduction. Yes.
Oh, is the load reduction from what time to what time?
From
11:7:38. You know, it's 5 hours.
Yes, sir, it's 5 hours.
Yeah, what hours was in the morning?
Recording in progress.
Okay, now you have 117,385,16. Okay, that's fine. So now what it means is therefore you have exactly 117,385.73. Okay, so that is the answer. But look at the fact that now this is a bit tricky. We used an extra factor here. We actually used an extra factor there. Any question? No question.
So, sir,
Yes.
I wanna recall what we did
Yes.
basically.
Okay.
So we used the 150 withdrawals to try and accumulate how much money was accumulated so that in 10 years' time there could be
Yes.
that withdrawal after each 5 years.
Yes.
And then we use the eight. Then we use the negative. We use the 18 for the remainder amount of years.
Yes.
Okay, I think.
Most definitely.
I
Or
think
that is actually what happens. That is actually what happens. So just to take that exactly into account. Right, we move on to the next question, right?
yes, sir.
Okay, good. We're good. We're good. Let's move on. Okay, here we have a collection of past exam questions, but there are so many, and we're interested in making sure that we practice. Let's start with something easy. A company bought a photocopier for 150,000. They bought it on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time on 30 June 2027. The average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. I'm giving you this question. Please let me know when you're done. Then we shall discuss it together. Please let me know when you're done. Then we shall discuss it together. Right. Please let me know when you're done.
So I'm done. I'm just
Yes, you're done.
typing
Okay,
it up.
good. Now, well done. I'm glad that you're done with this particular question. What did you do? How did you do it?
So I'm not sure if it's right, but I
Yeah.
said I used the appreciation formula
Use the
for.
reducing balance method. Okay, now something called the reducing balance method, the depreciation formula. Okay, so what did you do?
Oh, okay.
Yeah, so what did you do?
So um so didn't they want the new price of the new
Now, because they're
photocopier?
saying, yeah, determine the price of a new photocopier in 5 years' time.
So I said 1,000 one I said 150,000 and then
Yeah,
open brackets 1 plus 6,5 over 100 to the power
yes,
of 5. I'm not
yes.
sure. Yeah,
Yes,
that's what I did.
that's the correct answer.
Okay.
That's the correct answer because you need to determine the price of a new photocopier in 5 years' time. So now the price of a new photocopier, because we're speaking about a new machine, so it's going to be too expensive, but its value is going to increase um, right, it's gonna increase. So all right. Okay, let's check. So we're going to use 1 plus I because we understand that subject to inflation, the value is going to do what? It's going to increase. Okay, so obviously, well, it's going to be more expensive. So now we start with 150,000 1 plus. Now you have 6,5. You divide by 100. Okay, so good. Okay. Then now, because it is subject to inflation, so you just actually taking inflation into account. Because it is in 5 years' time. So you put 5 here. And therefore, this is approximately, let's use a calculator to check the answer. $150,000. 1 plus 6.5 to the 5th power. Okay, let's. Right, so which is 205. 205, 513. 205, 513. Let's check this one. 205, 513. Because it's 999, etc. 513. So in other words, the price of a similar new photocopy in 5 years' time, it's going to be exactly 205,513. Any question?
No, sir.
No question. We move on. The given information above, it's the same. That a company bought a photocopier for 150,000 on 1 July 2022. They will use the old photocopier as trade-in when they replace it with a similar photocopier, new photocopier in 5 years' time. So obviously this is in 5 years' time, on the 30th of June 2027. Calculate the trade-in value of the old photocopier after 5 years. If it depreciates at a rate of 9% per annum on a straight line method. Please do the straight line method depreciation and tell me what you got. Right, so we're good.
I did it, sir.
What answer did you get?
93,604,82.
Okay, let's just check that one. So now we're going to have that the straight line, according to the straight line method, depreciation. Then you're
Oh,
going to
no,
use,
sir. I made a mistake.
what did you do?
I raised it to the power instead of timesing it with the interest.
Okay,
It's
yeah, I get your point.
It's 82,500.
Well done. This 82,500. Right, because now you say the present value is 150,000. 1 minus the 9% divided by 100 is going to be 0.09. You multiply by 5 years according to the straight line depreciation method. answer. If you use your calculator, it's going to be exactly the answer we're going to achieve. $150,000. 1 minus 0.09 times 5, which is exactly 82,500. 82,500. And that is the answer. Any question on this one?
No, sir.
No question on this one. All right. So now we're going to obviously do the next one. And this is exactly what we do. We're not in a hurry, and we're trying to practice very, very well. So we actually now are moving to the next question. Right. So now in 6.1.3, there is a story. Now you need to calculate how much should be deposited at the end of each month so the company be able to buy the new photocopier. So in this particular question, you need to actually calculate the sinking fund. How much is the sinking fund? First, I'm asking that question. How much is the sinking fund? Because you are told that the company set up a sinking fund to cover the replacement cost of the new photocopier. Remember, this is the past metric paper, the one that we're looking at now. It's not that I've decided to bring this question. It's from past metric, like a few months ago. It's a new question, this. So you must be able to analyze it because it's going to be there, this one. They're just going to change some numbers. I'm telling you the truth. The company set up a sinking fund to cover the replacement cost of the new photocopier. The fund earns interest at a rate of 7.5% per annum compounded monthly. The company made its first monthly deposit on 31 July 2022 and will continue to do so until 31 May 2027. 1 month prior to the new photocopier being bought, how much should be deposited at the end of each month so that the company will be able to buy the new photocopier? I'm giving this one to you. It's a past metric question. It's a few months old. It just came from the Department of Education, national office, national examination, not provincial. But I want to see what you're gonna do. But I want you to first. I don't want to do the whole question because it's very long. Okay, and the marks are 4. But I want you to calculate the sinking fund because they set up a sinking fund. How much was the sinking fund here? So that's what I want. We're not in a hurry. We're not running. So do not run out of breath and run until you break your fingers or you burst your eyes because you're looking too hard. Should not be the case. Okay. The question is in front of you. The question is in front of you. The question is in front of you. Right. You tell me how far you are, and then we can see what to do.
So, sir, but I'm
Yes.
thinking,
Yes, what do you
right?
think? This is a past
The
metric paper. Right. So what do you think the answer is going to be?
so, sir, we're gonna use. So first, we're gonna have to find the amount that we're gonna be covering in order
Yes.
to find. So I'm thinking, you see, with 6.1.1, that 2,500 and
Yes.
2005, that number, that 200,000 number,
Yeah.
we the 8,000 to
Mm-hmm.
the 82,500, and then it gives us the F, and then you substitute the other values that it gave us, and
Okay.
then we have to, yeah, and then we find X. I don't know. That's how far I got.
Okay, that's fine. That's fine. Remember, we're practicing here. Like with me, I'm so relaxed. We still have 10 minutes. We still have 10 minutes. In the 10 minutes is more than enough time to finish this question. Okay, so I'm pausing to relax because it's one question we have. I want to make sure that you have the right skills in finance and you can do finance like no one's business. So that is like the objective, you know, that you
Yes,
must be
sir.
able to do finance like no one's what? Like no one's business. So, but what do I want you to do for me? I want you to calculate for me the sinking fund. How much is the sinking fund? Because the company set up a sinking fund. Until we get the sinking fund in this question, we shall not be able to do this question. We need the sinking fund first. They set up a sinking fund, but how much is the fund?
So I'm getting
Yeah.
123,013. I
Okay.
don't know that.
All right, that's fine. I'm not in a hurry because I want us to discuss this question a little bit more relaxed. The other questions I was giving to you were like my own questions, you know, but these ones are from the examination board. They're from the examination board, and therefore they are not questions that you need to undermine. They are tough questions, but not only it's not that maybe question of being tough, but they're like typical exam. We call them what? Typical exam questions altogether. So these ones are exactly the kinds of things you expect to find. It's not that, because now in my first training session, like in earlier today, I was looking at the kinds of questions, and some of the questions I gave earlier were like a bit above the exam standard. A little bit above the exam standard. Those deferred annuities and other things, they're a little bit above the exam standard. But now we are back at the exam standard. In the, yeah. So, okay, we're going to do it together now. But yeah, as I said, that my interest is in finding what? Is in finding the sinking fund. Remember that this lesson is recorded. So even if the sound breaks, you're gonna receive the recording and you still can watch it during your own time, okay? And you still
Yes.
can be able to see these questions. It doesn't matter that you be like, okay, we left with 7 minutes of time, so I'm not in a haste. I'm just responding to another student now as I'm here. Okay, it's not that I'm not just writing anything. But I want you, as I'm replying to this student, I want you to think about the question. So I'm going to keep quiet a little bit. Okay, this is just another student who is, I'm chatting to some other students on the group. You need to join our WhatsApp group, okay? So I'm going to, yeah, because already you can chat with other students. You are not on our WhatsApp. Are you on our WhatsApp group?
No, sir.
Okay, yeah. What is your province again? I don't know.
Gauteng.
Gauteng province. Okay. Okay, that's fine. Right, because yeah. You see, now I'm communicating with the students on the WhatsApp group. They should not be here, but now I'm going to be starting my other class at 8 altogether. So there's some of the students who are just, I'm chatting. So I'm going to send you the links to the WhatsApp group so that you see, you can get more practice questions from the group, because I normally post like questions on the WhatsApp group. Okay, we still have time right now. Okay, let us look at this particular question and solve it. Let's solve it together. Right, I was talking to my other students. Some of the students have joined now, and they should not, they should be joining, but now they're just from the WhatsApp group. So I'm gonna send you the links to the chemistry group. You do chemistry, okay? Right.
So
Okay, yeah, I'm gonna send you the links. Okay, even if I'm breaking because maybe I don't know, the device. Okay, here is the sinking fund. Right, note that at this point, you need to first find the sinking fund. And what is the sinking fund? The sinking fund is equal to, the formula for the sinking fund is A minus T. Right, so now we are able to see that the A we got would be, it's this one here. The A we got is this one. It's the price of a similar new machine. Altogether, the price of a similar new machine. Determine the price of a similar new photocopier in 5 years' time. It is 205, 513. Okay, so now the sinking fund, therefore, is going to be the price of a new machine, 513 minus 82, 500 minus 82,500. Now the 82,500 is this one. That is the trade-in value. Right, so that in the end, then we're able to get, if you use a calculator, this means that the sinking fund is equal to 123,013, which means the future value is x open bracket 1 plus I to the nth power minus 1 divided by I. Right, and then we're going to substitute everything. So we substitute and we then say we want to get x, because now they're saying how much should be deposited at the end of each month. So if we want, we can actually be in a position to just make x a subject. Making x a subject is going to be fi divided by, right, it's fi divided by 1 plus I to the nth power minus 1. One, two, three, 0, 1, 3. So now you're going to have exactly the following amount. So now this is going to be 123 multiplied by, just to lower it a little bit. Right, so this is exactly the same as x equals that, which means that x is equal to 123, the sinking fund 013 multiplied by the interest rate, which is the 7.85% per annum, but it's compounded monthly, so it's going to be 0.0785 divided by 12, all divided by, which is exactly this one, 1 plus 0.0785 divided by 12. And you raise it to You take note of the fact that this thing is happening for 5 years, which is 60 months. But now the company set up a sinking fund to cover the replacement cost of the new photocopier. The fund earns interest at the rate of 7.5% compounded monthly. The company made its first monthly deposit on 31 July 2022 and will continue to do so until 31 May 2027. 1 month prior the new photocopier being bought. Because it's 1 month prior, it means that it's going to be 59 here. It's not going to be 60 for the 5 years. Okay, so now it's 1 month prior. So it's going to be -1. Right. How much should be deposited at the end of each month so that the company will be able to buy the new photocopier? So now it's 1 month prior that these payments are going to be made. So you're going to be 60 minus 1, which is 59. Right. And that is what actually you were able to achieve here.
So
And now, yes, please. Yeah.
I got 1,715,7,16.
When you do all this.
Yes.
All right, good. But now then you're going to have to then say it is multiplied by 1 plus 0.0785 divided by 12. And you therefore multiply this one. Okay, let me put it at the bottom. Okay, check this out. Because of the 1 month prior, this is going to actually be, it's going to be compound interest for 1 month. Because now to take it to the 60th period, it's going to be 0.0785 divided by 12, like that. So it's sort of, this one is going to be like our P. Altogether, it's going to be like our P, because now they're going to continue to do so, but the company made its first, that will continue to do so until 1 month prior to the new photocopier being bought. So now you're going to multiply this, so it's going to, this is going to become like our P, so that you take it 1 month forward to the end. Right, and therefore it means that X, it's going to be, what answer did you get here?
I got 1704,01.
Well done, that's correct.
Yes, sir.
1704,01. That's the correct answer. What is your homework? This the next one is your homework. 3 minutes past 8. Right, the next one is your what? It's your homework.
Yes, sir.
Your homework is this one. Your homework is this one. Today, Andrew borrowed 200,000 from a bank. This question is about Andrew. The bank charges interest at 5.27 per annum, 5.25% per annum, compounded quarterly. Andrew will make repayments of 6,000 at the end of every 3 months. His first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? This is your home activity. This is your home activity. Any question? So this one you'll do during your own leisure because we are way beyond the time.
Yes, sir.
Okay, we're way beyond the time. All right, we thank you for joining us. It was awesome having this discussion. I'm going to post this. I'm going to make this recording available later on tonight because now I'm supposed to start another class at 8. Some of the students are already waiting. So yeah, I'm also going to send you the links to our WhatsApp groups so that you can like chat with other students. When you post material, you can like see material. You can ask questions on the WhatsApp group if you have questions, you know, and you'll receive assistance. Okay, right. We thank you for joining us. It was awesome having this discussion. Until next time, I'm going to check when else we're meeting again. Take care.
Yes, sir.
Goodbye.
Bye, sir.
Thanks. Goodbye.